Welcome to lesson 3-5, solving two-step equations. Now, in solving two-step equations, our objective today would be to, solve using two-step equations. So we're going to take our previous lessons of multiplying, dividing, and adding and subtracting and use what we've learned there. So a two-step equation, what is it? It's an equation that contains two operations: multiplication, division, adding, or subtracting. As you can see right here, in our first problem, our first example this is a two-step equation where you definitely see a multiplication and you see an addition. On this slide, they tell us to solve 5x minus 2 is equal to 13. So I'm going to take the problem out, and I get 5x minus 2 is equal to 13. This is a two-step equation. I have multiplication and I have subtraction. We're going to use this concept. The concept is backwards PEMDAS. In order to isolate my variable, the x, I'm going to work backwards. Normally I do adding subtraction last, but what I'm going to do here is I'm going to do adding or subtracting first. So you can see in my problem here, I have a minus 2, so I'm going to add a 2 to both sides, and I notice that when I add 2 it cancels out, it gives me 0, so I'm left with on the left side 5x, and when I add the 2 to the 13 I get 15. Then since this is a two-step equation, now I have to deal with the multiplication. What am I going to do there? I am going to isolate my variable by taking the opposite of multiplication and using division. I'm going to use division on both sides. I'm not going to use the 15. I'm going to use the 5, because if I divide by 5, I'll get a 1, which will leave me just an x, and that's what I wanted. X all by itself. 15 divided by 5 is 3. The answer is 3. Now it's time to check, which is just a plug and chug, which I'm going to take my solution and plug it into the original equation. So wherever there's an x, it becomes 3. And hopefully they'll be equal to each other. The left side should be equal to 13. So 3 times 5 is 15, minus 2 is 13. It checks. All right, in this problem, we have a two-step equation. I'm going to bring it on out so we can work with it. So 4 is equal to n divided by 6 plus 11. All right, remember I've used backwards PEMDAS. So what I really like to do is not work on the division problem, but work on the addition by subtracting, which is the opposite. And whatever I do on one side, I do on the other. And what happens here is that the 4 minus 11 gives me a negative 7. The n divided by 6 stays, and notice that the 11 and minus 11 cancel out or give me 0, so this is what I'm left with. My next step is to now isolate that n, and I'm going to use the reciprocal of this 6. That means that 6 is going to go on top, or I'm going to flip, if you remember that. Whatever I do on one side, I got to do on the other. So but these cancel each other out, or they multiplying by reciprocals give me 1, so that means I have 1n. And don't forget to multiply on the other side. My calculator says that 6 times negative 7 is a negative 42. So I do believe my solution is a negative 2. But I should always check my solutions, and that's what I'm going to do. So I'm going to take my n is equal to negative 42 and plug it in to our problem and check to see if I did it correctly. Alright, so following PEMDAS, negative 42 divided by 6 is negative 7 plus 11. Well, that's a 4, and that checks. Alright, this is a special case problem, so let's go ahead and write out the problem so we can work with it. So 4 minus x is equal to 10. Right, one of the things we need to look out for is that to get rid of the 4, and that's what we want to do first because we want to isolate that x, we need to get rid of it. So let's see here. What are we going to do? Are we going to add or are we going to subtract? Well, what we're really going to do is look in front. Since there's no sign, we know for sure that's a positive 4. So to get rid of a positive 4 or to get it to 0, I'm going to subtract 4. And of course, whatever we do on one side, I do to the other. Now 4 minus 4 gives me 0. I'm going to bring everything else down. So there's my negative, there's my x, and there's my equal sign. And I'm just going to go ahead and go 10 minus 4. It gives me 6. We can't stop there. We have to get rid of the negative. And in order to get rid of this negative, I'm going to use the division property. What do I mean by that? I'm going to divide both sides. And the key is to isolate the x. And really there is a 1 in front of the x. It's actually a negative 1. So how do I get rid of that? Well, I divide by the same number. Whatever I do on one side, I do on the other. And let's see, does it work it out? A negative 1 divided by a negative 1, two negatives make a positive, and 1 divided by 1 is 1. And notice that the 6 divided by a negative 1 changes to a negative 6. Let's check our work by plugging in our solution. So 4 minus a negative 6, put it inside parentheses so I can work with it, is equal to 10. Hopefully one side equals the other. Well, let's see here. We do remember that these two negatives change to a positive. So now I have 4 plus 6 is 10. 10 is equal to 10. Here's another problem we're going to encounter. We're going to have to do something more like simplifying, meaning that if we find some things that are in common, we should do that first before we do any of the properties that we've learned in the last two lessons. Notice here that these two are alike. So I'm going to solve that first. 5 minus 5m actually turns into a negative 4m. And once I did that, I have a two-step equation. I'm going to use backwards PEMDAS, meaning I'm going to do the adding and subtracting first. I get negative 4m. The opposites cancel out. I'll bring down the equal sign. 44 or 47 minus 3 is 44. Now I'm going to divide to get rid of that negative 4. I'm not just going to divide by a 4. I'm going to divide by a negative 4 because I want to keep it positive. Two negatives make a positive. 4 divided by 4 is 1, so I have 1m. I bring down the equal sign. And remembering whatever I do on one side, I do to the other. So that's where the negative 4 comes from. And when I divide, I get a negative 11. All right, I'm going to check, and I'm just going to go ahead and use this equation. So negative 4, my m was a negative 11, plus 3 is equal to 47. Type in my calculator, I get 44 plus 3 is equal to 47. Is that 47? Yes, it is. Solution works. In this slide, we have a word problem. It's sales. Mandy bought a DVD player. The sales clerk says that if she pays $80 now, her monthly payments will be $32. The total cost will be $400. And they did the equation for you, which is right here. Pay the $80 plus the $32 per month, and it should equal $400. How many months is the payments? So it's going to be pretty easy to figure out. But first thing is, we just need to write the problem out so we can work with it. It's a two-step equation. I'm going to focus it on the 80. The reason why is the 80 is the adding and subtracting. We're doing backwards PEMDAS. Okay, that cancels out. And I'm left with a 0 right here. That means I'll just bring down the 32x, the equal sign, and then 400 minus 80 is 320. Now, I'm going to go ahead and divide by 32 to isolate the x. X is equal to 10. And just so you know, the question goes, how many months will it take? Well, that's what 10 means. 10 means months. So I should put a unit there because it's a word problem.